All right, in this video we're looking at geometric series. Okay, a geometric sequence is when you have like a common multiplier or ratio, like 2 times 3 would be 6, 6 times 3 would be 18, 18 times 3 is 54, 54 times 3 would be 162, and so on. A series is when I add these numbers together. This is a geometric series. And so if I add these up, that's going to be 8, 26, 80, that'd be 242. Okay? All right, well, we can add these numbers up a little bit easier by using this formula. Where S of n, where n's the number of terms. A sub 1, of course, that's your first term. And then here's my common ratio, which is how much it goes up each time by a multiplier. And then, of course, n, again, the number of terms. And then R, your ratio down here again. So if I use this formula for up here, and I don't know if I can have it on the screen. I'll just rewrite my. It's 2 plus 6 plus 18 plus 54 plus 162. Okay, so if I use the formula to do this, I want to find the sum of these 1, 2, 3, 4, 5 terms. It's going to be the first term, which is 2, times my ratio, which it goes up 3 each time, so 3 to the 5 power minus 1, and it's divided by 3 again, minus 1. Okay, and I just punch this in the calculator. Now, one thing you do have to note, when you punch this in the calculator, you have to put parentheses around this bottom right here. Okay, so let's try this. So I've got 2, then I have 3 to the 5th power minus 1 in parentheses divided by 3 minus 1. And you can just do 3 minus 1 in your head, just put divide by 2. But there you go, 242, and that's what we had gotten a while ago, 242. So that's how you can find the sum of a geometric series. Okay, let's look at some of these problems. Number 1, use the formula to find the sum of the first 7 terms of this sequence. All right, so I want to find the sum of these 7 terms. Okay, it's going to be this first term, 3, times, and my common ratio, it looks like it multiplies by 2 each time, so R is 2, and it's to the 7th power, n is 7, minus 1, and then divided by down here, 2 minus 1. And of course, when I punch this in, I got to put parentheses around that there. Or I can just do 2 minus 1, which is just 1, and divide by 1. Okay, so on this one, I got 3 parentheses, then 2 to the 7 power, minus 1, parentheses, divide by 2 minus 1, and here we go, 381. 381 is my sum. Okay, now let's just check this. So here's 1, 2, 3, 4 terms. My next term would be 48. That's the 5th term. Then 96, and then 192, and I believe that's 1, 2, 3, 4, 5, 6. There's my 7 numbers. So let's add these up and see if we get 381. So 9, 21, 45, and 48, it'd be 93, plus 96, plus 192, and I got 381. Yeah, we did. So we're in good shape. All right, let's go to number 2 here. Find the sum of these first 6 terms here. So n is 6. My R here, it goes up, it looks like negative 6 divided by 2 is negative 3. 18 divided by negative 6 is negative 3, so there's my R. So basically I just need this n and R. So the sum of these first 6 terms is going to be the first term now, which is 2 there. I need that one too. Then I have negative 3. Now here's one thing here. Since this R is negative, I'm going to have to put parentheses around that negative 3. It's to the 6th power minus 1, and then it's divided by negative 3 minus 1. But when I do this to the 6th power, that's going to have to be in parentheses. So let's see here. 2, and then parentheses, -3, parentheses to the 6th power, then -1, and then divide by -3 minus 1. And there we go, -364. There's my sum. Okay. Use the formula for SN to find the first 8 terms. So N is 8 this time. Here's my first term right there. That's A sub 1. And my R, if I do 10/3 divide by 5/3. Oh, it's right over here. 10/3 divided by 5/3. You can just punch this in the calculator. If you do, you have to put parentheses around it. Or you could change it to multiply and do this, and these will cancel, and this cancels. It's 2. But you just type it on the, I'm sorry, you can type this in on the calculator. But you got to put parentheses around them. But there you go, R is 2. Okay. So the sum of these 8 numbers is going to be the first one, 5/3, times 2 to the 8th power minus 1 divided by 2 minus 1. Okay. So let's see here, 5/3 times 2 to the 8th power minus 1, and then divide by 2 minus 1, and there you go, 425. Okay. That's what I do when I add all these up. I thought about doing this one. You can check it, but I did this earlier, and that's the same thing I got earlier, so I added them up individually. So I think it's good. All right, so let's go to number 4 here. Use a formula to find the first 7 terms. All right, so that means N is 7. My R, if I do 10/3 divide by 5, just type it in here, but put your 10/3 in parentheses, divide by, and then 5, since it's just 5, I can just divide by 5. Don't have to put it in parentheses, but there you go, it's 2/3. So R is 2/3, and then here's my A sub 1 right there. So those are 3 things you need. So the sum of these 7 terms is going to be 5 times, and since this is 2/3 here, this is going to have to be in parentheses to do this 7 power. Anytime you have something that's like a fraction or a negative, this is going to have to be in parentheses. And then 2/3 minus 1. You don't have to do it down here because it's not to a power. It's when it's to a power like this, you have to put it in parentheses. So we just type this in. So 5, and I got double parentheses, and I got 2/3. Close that up to the 7 power minus 1, divide by, and then I got 2/3 minus 1. And I got 14.122. Now, if I change it to a fraction, it comes out to be this. Oh, I didn't have it on the screen very good. So that's 10,295 over 729. Okay. Use the formula to find the sum here of the first 7 terms. So it tells me A sub 1, it tells me what R is, and then of course N is 7. So I just put these numbers in the formula. So S of 7 is going to be A sub 1, which is 3.254. Then I have 2.275 to the 7 power minus 1, and then down here 2.275 minus 1. That has to be in parentheses when I punch it in. All right, so 3.254, and then 2.275 to the 7 power minus 1, divide by, and then 2.275 minus 1. And there it is right there, 802.41. think it would ask you to round it maybe 3 places. So 802.413. That's my sum. Okay, here's a similar problem. I'm just going to skip that one. All right, use the formula to find the first 7 terms here. So here's my a sub 1. My r, it looks like 12 divided by 3 is 4. 48 divided by 12 is 4. 192 divided by 48 is 4. So r is 4. And n says 7 terms, so n is 7. So there's the 3 numbers I need. S of 7 equals, okay, so I'm going to have my first term 3 times 4 to the 7 power minus 1 over 4 minus 1. Okay, of course when I type it in, that's got to be in parentheses. So 3 to the 3, and then 4 to the 7 power minus 1 divided by 4 minus 1. And there you go, 16,383. Maybe you can practice, while I punch this in, maybe you could practice punching in, make sure you're punching them in right. That might be a good idea. Now, then we got them in sigma notation. Basically, this means k equals 1 to 8. We're going to add up the terms from 1 to 8. And we'll do this one both ways. So if I put 1 in here, 4 times 3 to the 1 power would be 12. If I put 2 in, 4 times 3 squared would be 36. If I put 3 in, 4 times 3 to the 3rd power. Okay, here, I have to bring the calculator. I think it's 112 or something. Let's see here. Or 108, I don't know. Okay, 4, 3 to the 3rd power. Yep, 108. All right, now I'm just going to go back in here and change it to a 4. That's 324. 5 would be 972. Put 6 in. So I'm just going to change my formula here to a 6. That's 2916. Change it to a 7. That's 8748. I'm running out of room here. And then the last one is right down here, 26244. All right, so here's my 8 numbers. All right, so if I add those up, I'm going to punch those in real quick. All right, there you go, 39,360. So when I add up all these terms from this sequence, I get 39,360. Now let's use the formula, because in this, a sub 1, if I put 1 in here, 4 times 3 to the 1 power is 12. Okay. My r, this number right here is always going to be our r. And then my n, 8 minus 0 would be 8. And so there's my 3 numbers I'm going to put in the formula. So the sum of these 8 numbers is going to be a sub 1, which is 12, times the ratio 3 to the 8 power minus 1 divided by 3 minus 1. So I punch this in. Of course, remember, this has to be in parentheses down here when I punch it in. All right, so let's give it a shot. 12, 3 to the 8th power minus 1 divided by 3 minus 1, and 39,360. Look at that, man, we got it. 39,360. Okay, so what would my sum be here? So from 1 to 6, I'll do this one both ways too, since there's only 6 of them. So if I put 1 in there, 3, and then negative 4 to the 1 power, this is negative 12. I'll put them in parentheses. And then change it to the second power, which is 48. Change it to the 3 power. Now you don't have to do it this way. I'm just doing it to show you that it does work out. This is 768. Negative 3072. And then one more. I'll write down here. Right. All right, so there's my 6 numbers. I'm going to add them. So let's punch them in here. So there's what I get, 9828. That's the sum I get. Now let's use the formula. So the formula, of course, here's a sub 1 right there, negative 12, and I just put 1 right here. See, 3 times negative 4 to the 1 power is negative 12, so there's a sub 1. My R is this number right here, and my N, it says from 1 to 6, 6 minus 0 is 6, so there's these 3 numbers. I'm going to put those, making a mess. So the sum of these 6 numbers is going to be the first one, which is negative 12, times my ratio of negative 4. Remember, that's going to have to be in parentheses itself since it's negative. And of course, this will have to be in parentheses down here when I punch it in. So let's try it. Negative 12, double parentheses, and negative 4 to the 6th power minus 1 divided by negative 4 minus 1. And I got 9828. Look at there, man. 9828. Okay. Number 10. All right, so we'll just do this the normal way. We're not going to do it both ways this time. All right, so what's a sub 1? I put 1 in right here. So let's do that. 2/3 times 5 in parentheses to the 1 power. I'm putting 1 in for K right there, and it looks like, all right, we're going to, let's change to a fraction. 10/3. There's a sub 1. Okay, my R is this number right there, 5. And N, all right, we're doing from 1 to 6, so 6 minus 0 is 6. There's my 3 numbers I need. Okay, so the sum of these 6 numbers is going to be the first one, 10/3, times my ratio, 5 to the 6th power minus 1, divided by 5 minus 1. Okay, and so when I punch this in, 10/3, in parentheses, 5 to the 6th power minus 1, divided by, and then 5 minus 1 on the bottom in parentheses. And there you go, 13,020. Okay. Now we got a couple word problems. Number 11. A sequence of yearly payments of $5,000 is invested at an interest rate of 6.5% compounded annually. What is the total of the annuity after 8 years? This is what people do. I know several people that have put money away like this every year, and they end up, when they retire, they've got a big old load of money that they have in their bank account because they've invested it. But they're putting $5,000 in every year. All right, so a sub 1 is that $5,000. Okay, my ratio here, all right, now it's invested at this interest rate, which is 6.5%. Now if I move that decimal back 2 places, I get 0.065. I got to change this percent to a decimal. But I have to add 1 to it because it's increasing this much. So it's going to have the 5,000 plus this extra. So that's why I'm adding the 1, because it's 5,000 times the 1. So actually my rate is going to be 1.065. Okay. So I change this to a decimal, and I add 1 to it. And then n is 8, because we're doing this for 8 years. So here's my 3 numbers. So the sum of the 8 terms is going to be 5,000 times 1.065 to the 8 power minus 1 divided by 1.065 minus 1. And of course that has to be in parentheses when I punch this in. So let's see here. Get it moved over so you can see it better. 5,000. Then I have 1.065 to the 8 power minus 1. Then divide by, and then down here I got 1.065 minus 1. And there you go, $50,384. That's how much money this person's going to have. And that's just 8 years. Which means 8 years. See, if he puts $5,000 in a year, times that by 8, that's $40,000 he's put in. But yet, it's $50,000 because he's earned interest. All right, so a couple more problems. This is find the future value of this annuity. There's payments of $500 at the end of each year for 8 years, and it's 11%. So just like we did a while ago, now a sub 1 is the 500. My ratio is going to see this percent. If I move that back 2 places, it's 0.11. So I add 1 to it, which is 1.11. And then, of course, my n is 8. Right there. So there's the 3 numbers I need. So my sum of these 8 years is going to be 500 times 1.11 to the 8 power minus 1. There should be minus 1 divided by 1.11 minus 1. Okay, so we're looking at 500, 1.11 to the 8 power minus 1 divided by 1.11 minus 1. And oh, I didn't hit my decimal very good. There you go, $7,115 and 66 cents. That's how much money you have. This shows you how much money you have if you put it away and save it, let it earn interest. And especially this one right here. This is a real good one to look at. This person says, save for retirement, you decide to deposit $2,000 into an IRA at the end of each year. So $2,000 every year goes in this IRA for 38 years. If the interest rate is 8% per year compounded annually, find the value of the IRA rounded to the nearest dollar after 38 years. So here, my A sub 1 is going to be the 2,000. My ratio here, since this is 8%, that's 0.08, so I add 1 to it, which is 1.08. And then my n looks like 38 years. Now, how much is this going to be worth? You're going to be shocked when you see how much money this is going to, just $2,000 a year, putting it away. The sum of these 38 years is going to be 2,000. Then right here, I'm going to have 1.08 to the 38 power minus 1 divided by 1.08 minus 1. And of course, when you punch this in, I have to have parentheses around that. Okay, get ready now. It's going to shock you. 2,000, 1.08 to the 38 power minus 1 divided by 1.08 minus 1. And there it is. Look at that, $440,000. 440,631, and then 89 cents. There you go. That's how much money you got. Just $2,000 a year. Just think what it'd be if you put more than that. What if you put $4,000 a year? Let's go change it. What if it was $4,000 a year you put in there? Look, it's going to be $881,000. Almost $1 million. What if you put 5,000? I bet it'd be $1 million if you put 5,000 in there. Yep, look at that, over $1 million. So if you want to be a millionaire, put $5,000 away each year for 38 years, and you'll have over $1 million. Anyway, that's all we're doing for geometric series. So if you have any questions or anything, let me know and I'll help you all I can. Have a good rest of the day.